Welcome to this explainer. Okay, today we are taking an absolutely mind-bending cosmic journey. We're going to start out in the most terrifyingly empty place in the known universe and eventually travel all the way down to the chaotic engines driving our very own galaxy. Let's get right into it. Imagine a little animated stickman. Let's just say that's you for a second, floating right in the middle of a pocket of space so vast and so incredibly desolate, but it literally challenges our entire understanding of the cosmos. I mean, what does it actually mean to be surrounded by hundreds of millions of light years of absolute, total nothingness? Well, the answer lies in a place called the Boude's Void, and this void stretches an incomprehensible 330 million light years across. To put that kind of scale into perspective, it takes light, literally the fastest thing in the entire universe, 330 million years just to cross it from one side to the other. It is hands down one of the deepest, darkest, and most desolate voids humanity has ever discovered. Now here is where it gets weird. Despite its massive size, this entire expanse contains only 60 known galaxies. Normally, a pocket of space this unbelievably huge should be teeming with around 2,000 galaxies. But instead, it's essentially a ghost town. Just 60 lonely islands of stars drifting in an endless ocean of pitch black. Section 1. The Grand Cosmic Web. To really get a grip on how weird this is, we have to zoom out. On one side, we have the whole observable universe, packed with an estimated 2 trillion galaxies. It's this massive, bustling metropolis of stars and planets. But then on the flip side, you have the Boots Void, with a measly 60 galaxies. It really makes you wonder, how could such an immense pocket of nothingness even form in the first place? Well, it all started 13.8 billion years ago with a Big Bang, which was followed by the Dark Ages. This was a period long before the first stars even existed. Over billions of years, gravity pulled neutral hydrogen and helium together into this intricate, glowing structure that we now call the cosmic web. It's basically a network of superclusters and filaments, and as all that matter clumped together, it left behind massive, empty voids. Voids exactly like Boots. But here's the thing, we don't actually have to look millions of light years away to find bubbles in space. If we zoom right down into our own galactic neighborhood, our solar system actually sits inside a 1,000 light-year wide cavity known as the local bubble. About 14 million years ago, a series of roughly 15 massive supernovae exploded, pushing all this interstellar gas outward and carving out the very bubble we're drifting through today. Pretty wild, right? Section 2. Monsters in the dark. Of course, the universe isn't just empty bubbles and voids. There are some truly extreme things hiding out there in the dark. Take the gravistar, for example. It's a theorized alternative to black holes. So instead of a singularity crunching down to infinite density, a gravistar has precisely zero internal gravity. It's essentially a shell held up by a core completely filled with vacuum energy. If our little stickman friend were to drop into one, they wouldn't get crushed into nothingness. They'd hit this perfect balance, countering the crushing force of gravity. Or consider the white hole. This is basically the space-time analog of a traffic cone. Mathematically predicted by loop quantum gravity, it's the exact opposite of a black hole. It has an event horizon that works entirely in reverse. Light and information can leave a white hole, but absolutely nothing, not even our stickman traveling at the speed of light, can ever enter it. So how do monsters like this actually form? Well, the James Webb Space Telescope recently discovered early universe black holes that are totally rewriting our understanding of this. See, local black holes in our era have about a 1 to 1,000 mass ratio compared to their host galaxies. But in the early universe, JWST found black holes with a 1-to-1 ratio. They were almost as massive as the galaxies containing them. This strongly hints that they didn't just grow slowly over time, but actually collapsed directly from pristine gas clouds. Section 3. Exploring our solar system. Let's step back from deep space for a second, because right here at home, we have pristine time capsules like asteroid Bennu. Bennu coalesced 4.5 billion years ago, and because it's been perfectly preserved in the cold vacuum of space, samples brought back to Earth show exceptionally high abundances of frozen volatiles, things like water, methane, and ammonia. Imagine our stickman standing on this ancient icy rock. They'd literally be looking at the raw ingredients for life, preserved right from the dawn of our solar system. And as we study our origins, our physical reach just keeps expanding. Voyager 1 looked back from a staggering 6 billion kilometers away to capture our home, the famous pale blue dot. As Carl Sagan so poetically noted, it is a small speck in the immense universe. That single amazing image beautifully anchors our place within this vast cosmic web.
Section 4. Tools of Cosmic Discovery. So, how do we actually know all this stuff? Well, we rely on intrepid voyagers. We have Maven, which taught us that solar winds strip 100 grams of Mars' atmosphere every single second. Then there's Juice, heading out to Jupiter, packed with 3,000 kilograms of propellant just to navigate some insanely complex gravity assists. And I absolutely love this one, the Europa Clipper. It's carrying a tantalum plate engraved with a poem and the word water in 103 different human languages, destined for Jupiter's icy moon. And while we're sending probes out, we're also building these monumental observatories. JWST gives us the unprecedented sensitivity to peer back 13.5 billion years in time. And the Vera-C-Rubin Observatory? It boasts a 3.2 gigapixel camera with the goal of capturing 20 billion galaxies. It's going to give us the most complete map of our cosmic neighborhood ever created, showing us exactly where we sit in all this grand architecture. But hey, we don't just look at the universe anymore, we actually listen to it. Observatories like LIGO allow us to detect gravitational waves. These are literally ripples in the fabric of space-time caused by binary black hole mergers, supermassive black holes spiraling together, or they're detected through pulsar timing rays. We are literally tuning into a massive cosmic symphony of extreme gravity. Section 5. The Macro Return. Which brings us back out to the largest scales. Some scientists theorize that remnants from the Big Bang might actually still be out there. Cosmic strings, these massive, one-dimensional flaws in the very fabric of space-time, could stretch across the entire observable universe. If they exist, and if they decay, they might be rippling out gravitational waves from the absolute darkest, emptiest corners of space. And that leaves us with a truly profound mystery. In a universe this unbelievably dense, this chaotic, filled with black holes and a glowing web of 2 trillion galaxies, what is genuinely lurking in the absolute silence of the Boots void? If your little stickman self was floating out there in the dark, would you really be entirely alone? Or would you be surrounded by ancient secrets we haven't even begun to imagine? Keep looking up and stay curious.